Good evening, everyone. Our host for the today's webinar, Dr. Sesa S. Srinivasan, respected colleague, friends, and students. I, Dr. Sanjay Kumar Misra, feel glad to welcome you all to the third and final series of today's webinar, organized by Applied Science and Humanities Department of IT Engineering College, Greater Noida, India. The third and final series of our series is based on the topic the renewable energy systems and sustainability, education, research, and outreach. In this session, our guest speaker would be Dr. Sesa S. Srinivasan, Chair, Department of Natural Sciences, Florida Polytechnic University, Lakeland, USA. Now, I would request Dr. Sesa S. Srinivasan to give his talk. Thank you, sir. Please.
Thank you. Thank you, Dr. Mishra. First of all, I would like to thank ITS Engineering College, Humanities and Applied Sciences Physics Department for providing me this, at least bear with me for 3 lectures in series for the renewable energy and sustainability talks. Today is a final talk. We will start. Again, I would like to extend my thanks to the institution and Dr. Sanjay Kumar Mishra. With that, I would like to share my screen. So this is my presentation today. Is again, I'm continuing with those who are not speaking, please turn your microphone to mute so that you can hear me clearly. So I will set up my timer for 30 minutes. All right. So this talk today, I have focused more close to the hydrogen technologies, hydrogen energy and fuel cell technologies, because in the last talk, Dr. PC Jha from ITS Chemistry Department, I have some disturbances. Can you please put yourself in mute?
Please
the hydrogen technologies and the hydrogen fuel cell technologies, which I will be continuing my talk. I don't know, is this me or is this somebody else? All right. So today we will see about a little bit on the hydrogen cycle source regeneration. Hydrogen is, everyone knows that it's plentifully available from water. You can split the water and produce a hydrogen. The hydrogen can use it, hydrogen you can produce from the water. Then you can use hydrogen into the engine. You can combust the hydrogen. Is this some disturbance, Dr. Mishra? If someone is...
Yeah. Please mute yourself.
Yeah, thank you.
Please.
Hello. Yeah. The hydrogen can be combusted in IC engine. I don't know, is this my microphone or? Okay. So the hydrogen, Dr. Mishra,
please. I request you, please don't make a noise. Please, there is some noise. Please ignore.
Okay. I don't know whether it's coming from me or something. I don't know. This is, anyway, I will continue this. Hydrogen you can produce from the water and use it as an engine to burn the hydrogen, or combust the hydrogen using hydrogen combust in an engine, or you can store the hydrogen in a metal hydrides or any other medium. The overall byproduct of the hydrogen combustion is oxygen. Oxygen is very benign that you can use it for breathing. So it is not contributing any of the carbon dioxide or carbon monoxide. It is free from the greenhouse gases. There are challenges in using the hydrogen technologies for fuel cells or internal combustion engine application. Okay, so let's look into the deeper side of it. In order to produce hydrogen, in order to use the hydrogen for your vehicular application or any stationary application,
हाँ तो
then
मतलब
the hydrogen production must be
हाँ तो
uh,
मतलब
$2 per kilogram. You need to produce within the range of the cost. For every kilogram of hydrogen you produce, you have to spend at least $2. Right now, we are spending more, like $16 to $20 per kilogram. So that is a challenge. The second thing is hydrogen need to get stored, because if we don't store the hydrogen, you cannot use the water to run the water to produce hydrogen and run it constantly. You need a storage device. The storage device, in order to get a cost, you need at least $8 down per kilowatt hour of the hydrogen storage. Hydrogen storage is a big challenge too. So hydrogen, in order to implement the hydrogen for the production and storage and the utilization, it's all to work out simultaneously so that you can use the hydrogen in fuel cells. I want to tell what is fuel cell. Fuel cell is a technology where hydrogen can be combined to oxygen. Basically, hydrogen H2 plus O2 gives electricity. So you produce electrons. So that's a technology which I'm talking about for this today's topic. For what is fuel cell? The fuel cell uses the hydrogen, and then fuel cell also use oxygen to combine. You produce the output you produce is water, but you can produce the electrons to store. The electron is good for producing electricity. Therefore, fuel cell is nothing but a reverse electrolysis. You can use a reverse electrolysis. The challenges with the fuel cell is it has to be secured with energy, resiliency, affordability, and strong domestic usage. So there are big challenges like the transportation sector and the stationary applications. You need to use fuel cells that uses the hydrogen that produced from the water or fossil fuels. So we'll talk about that. What are the objectives for the hydrogen production? The hydrogen production, the objectives are you need to produce a low cost, highly efficient technologies for producing hydrogen from domestic resources. Like you can produce hydrogen from solar
मैडम
photovoltaics,
आपके फोन से आवाज आ रहा है सिर घर में
solar
आपके
PV, or solar
आपके फोन
electrolysis.
से
You
आवाज
can
आ रहा है सेमिनार में
solar PV or electrolysis you can produce, or you can store it in a high pressure cylinders or metal hydrates. So the number of technologies have been discovered and developed for storing the hydrogen for heavy duty transportation or stationary applications. So when I say hydrogen production, you need to produce a hydrogen sustainably and produce from the renewable energy sources like water, like sun, or like nuclear, or any other non-renewable sources you cannot use. You need to use only the renewable sources. For hydrogen fuel cells, because the hydrogen will combine with the oxygen, the hydrogen fuel cells used for the transportation sector, they use for the backup power or any of the laptop or any electronic applications. Therefore, the fuel cell power is nothing but you are taking the hydrogen and oxygen, convert into the electricity to drive your vehicles. This is completely free from carbon dioxide. The cost is very challenging because producing hydrogen, you are right now you have to always go with the gallons of gasoline equivalent. Right now we are using in your car and vehicles, use gasoline. In the US we say it's a gasoline. It's the same thing like a petrol. petroleum. So you need to convert that in terms of prices. For right now, the gasoline gallon equivalent is $16 for every gallon. 1 gallon is 4 liters. 4 liters of gasoline or kerosene or petroleum is equal to $16. But the Department of Energy wanted the ultimate target to go down to $5 per gram equivalent of gasoline. So that's a challenge there. There's a big gap there. You're going from natural gas, fossil fuel to produce a hydrogen to the electrolysis. You go with the electrolysis process, which is highly renewable compared to the natural gas. You can also produce a hydrogen from methane. CH4 is methane. You get the carbon plus H2. You can get that, but that's having some carbon footprints. Then hydrogen need to be stored. The hydrogen storage right now, they use a hydrogen in 700 bars, 700 atmospheres of hydrogen stored in a compressed cylinders. They use right now $21 you pay for to store that 700 atmospheres of hydrogen per kilowatt hour. But that cost has to go down. That's a big challenge as well. So, and then big implementation is the fuel cells. Fuel cells are very expensive, but it can be applied for clean energy and the green energy. Right now, the fuel cell cost for every kilowatt of energy you produce, you have to spend $40 per kilowatt. That's very expensive. But Department of Energy asks you to produce up to $30. You can come down a cost, and then you can keep the 65% efficiency, and the durability should be increased to 8,000 hours. Right now, you and I will drive the gasoline car. The gasoline engine, ICE engine, internal combustion engine, the efficiency is only 30%. Rest of the 70% are going as a waste heat. So the fuel cell is a device which converts up to 65% of the efficiency, which is 2 times or 3 times more than the internal combustion engines. Okay, that's why we are going for fuel cells. The production has different types of producing hydrogen. You can either produce from the fossil fuels or the coal, because in the US we are, or in India we have a repository of coal. You can produce a coal, burning the coal. You can also produce a hydrogen using steam methane reforming, that is SMR, or you can produce from waste products like biomass feed, like a digester. You can use a digester technology to produce a hydrogen, or you can produce by solar PV photovoltaics like low temperature electrolysis, high temperature electrolysis, or direct solar thermochemical. Solar thermochemical means you have a solar energy and the thermochemical reaction occurs, you produce hydrogen. So each technology has got pros and cons, or advantages and disadvantages. So you need to understand that why the hydrogen is taking too much time to come into the market, because there are intrinsic problems with each technology to address, not like electric vehicles last week I was talking about. The same thing, hydrogen storage. You can store, why we need to store hydrogen? Because otherwise, hydrogen is a very lightest gas. If you just burn the hydrogen, it will evaporate. So once if it leaks, then all the hydrogen gone out. You need to store in a high pressure cylinders like composite cylinders, or liquid hydrogen like the BMW cars are running with the liquid hydrogen like cryocompressed liquid hydrogen, or you can store in a low pressure hydrogen carriers like a materials. Like materials technology is very, I'm working on the hydrogen storage, where we have to develop materials for storing reversibly hydrogen like carbon materials, single one nanotubes, or graphene, or any complex materials you can store it. So there's a big challenge. The scale of hydrogen storing has to be increased. Okay, so that is very essential to keep up. And then the fuel cell technology, as I said, we need to increase the durability to 8,000 hours, or you can reduce the cost by 30 kilowatts. There are big gaps. See, there are big gaps need to be challenged. The fuel cell is a process where you need electrodes. It's a electrochemistry where you have to use a membrane or catalyst layer or gas diffusion layer, internal gasket or bipolar plates. So this is a whole technology has to be developed, that the membranes has to develop. You have to develop a PGM. What they call PGM means lead membrane, lead based materials. You should not, in the market right now, you are not supposed to use lead. Lead is very toxic, lead is very poisonous. So you need to go for lead free membrane materials or electrocatalysts. So that means, that's why we call it a PGM free. PGM is a lead based materials. You are not supposed to use a lead base to developing this, the whole catalyst for working for the fuel cells. Okay, that's a big challenge. There are many gaps to be need to be filled out so that you can get the hydrogen fuel cell cars into the market and commercialize. Okay, so for production or the utilization, hydrogen is a source of energy. You can, if you calculate the equivalency of the gasoline with the hydrogen, hydrogen is 2 or 3 times more than the gas equivalents in terms of energy density. So the energy density is higher, so that you can use it for transportation or use it for the syngas protection. You can also produce synthetic gases, or you can produce for the combined heat cycles or metal refining. Hydrogen can be used for many processes. At the same time, hydrogen can also be used for electricity production, for your grid electricity, and you can use it for the renewable energy as a hydrogen as a renewable energy sources. So when I was working with the BHU, Banaras Hindu University, I worked heavily with one of the professors, Professor Vayan Srivastava, who is a Padma Shri awardee. So working on these hydrogen technologies for the vehicle transportations. So overall, in order to have the hydrogens to come into market, your materials need to be designed uniquely. Your materials need to be designed uniquely, so that you can get materials development, so that the discovery of the materials and development of the material, optimization, system integration, and certification. All this process goes in a chain reaction, so that you can get the hydrogen compatible materials, or breakthrough in hydrogen storage, or advanced splitting of hydrogen production, or the fuel cell developments. So it's a big R&D which is needed the materials for working for different sectors. All right, for production, you have 3 different techniques or 4 different techniques. You can use photoelectrochemical using solar hydrogen production, or you can use direct solar thermochemical hydrogen production, or low temperature electrolysis or high temperature electrolysis. There are a number of energy labs in the US and in India. They're working on solar hydrogen production, so that you can keep up the cost, or at least cut down the cost, so that you can use it for the hydrogen for your fuel cell applications. Number of techniques, as I said, that's a low temperature electrolysis. The whole new area of lead-free membranes, electrocatalyst need to be developed, anion exchange membranes that needs to be developed, and electrodes. So it's a big electrochemistry over there, that you need to develop the material science and to improve the electrodes and electrocatalyst. The same thing for photoelectrochemistry. We also again to go for PG free catalyst. Then you have to use earth abundant catalyst or layered perovskites tandem junctions. So because right now the photoelectrochemical hydrogen production is about 15% efficiency. It's not a lot. So you need to go for triple junction or multiple junction tandem junction solar cells, so that you can increase the efficiency to 30 to 45%. That's ideal for converting the hydrogen into water into hydrogen and use it for the fuel cells. Solar thermochemical, you need to have a reactor material which should be stable at a very high temperatures. Then high temperature electrocatalyst, again work with the temperature stability and metal support catalyst you need to develop. Overall, this is a story about how you can use the fuel cells in two different processes. The one process is called electrolyzer. Electrolyzer, as an electrolyzer, the RFC stands for reversible fuel cells. The fuel cell is nothing but two electrodes. You have a cathode and anode separated by an electrolyte that produce the hydrogen to go into the electrolyte, and then it react to produce the energy. Okay, so the first initial electrolyzer mode, where the hydrogen is produced from the water is plenty of hydrogen that goes feed into the fuel cell. Okay, and the electron is coming from your electricity coming from the utilities. Then the hydrogen to electron, it produce the hydrogen gas. So that means it's a water splitting. You need to split the water into hydrogen oxygen. So hydrogen can go in a vehicle, the storage device, and oxygen can go into the atmosphere. Whereas in the first process, when I feed the hydrogen and oxygen back, I can produce my electricity back. So that's a reversible fuel cell which does the job. The main thing is your production need to be improved, and your storage needs to be improved, and your fuel cell need to be improved. So this is a big challenge, but it's a doable challenge. We are working on hydrogen storage, and also we are working on hydrogen production and fuel cell to some extent. At when I was at my previous institution, so this is me from Tuskegee University, we were working on a hydrogen fueling station infrastructure. Last week, Dr. Java was asking why the hydrogen technology is not coming to the market. The big bottleneck or the roadblock is the infrastructure development. You need to develop the stations, hydrogen fueling stations infrastructure, so that you can produce the hydrogen straight on board. Do it instantaneously. Like the fuel cell development, if you look at from 1839 all the way to 2020, many companies like General Motors, BMW, the Honda vehicle, every car manufacturers, they are for alternative vehicles, where you can go with the all electric or plug-in hybrid or fuel cells. So this is a big R&D to go for using the hydrogen technologies so that you can reduce the global warming or carbon dioxide footprints. The difference between the process of a direct hydrogen tank. So you can have your hydrogen tank into the car, and the hydrogen tank, you need to store the hydrogen and use the hydrogen, and you use the external power so that you can feed electricity, and hydrogen is there, can work and produce power. Like that's a minus. Electricity done by one process called the direct hydrogen usage for fuel cells. Or the second one is reversible electric vehicles. You need to have a charging station in between for the vehicle, so that the charging station feed the hydrogen come from this charging station, and the electric vehicle or fuel cell convert that hydrogen back to produce electricity. So, so the main thing is about the infrastructure. We get the infrastructure so that this technology can be very viable for us. Right now, if you look, there are a number of ways you can produce hydrogen, like gaseous hydrogen or liquid hydrogen or pipelines or total hydrogen. So the total hydrogen demand is going exponentially. So it is increasing exponentially, so that to cater the needs of the hydrogen, I got this. I can finish what I have. So there is a big demand of the exponential hydrogen demand. You have number of technology like steam methane reforming or liquid hydrogen. You have to liquefy the hydrogen. You need to go to minus 21 degrees Celsius, or probably minus 200 something, 220 degrees Fahrenheit. So that's a very low temperature. You need to cool the hydrogen below liquid nitrogen, or you can use on-site electrolysis or gaseous hydrogen. You can use it. But still, we are not yet there to reach the demand, which is exponentially increasing. So right now the fuel cell, okay, so I'm running out of time, it says. So I will just go skip the slide. So this is a fuel cell technology. How the hydrogen work here, hydrogen combined with the electrons to produce water. The water is a final exhaust. So this keep on working with the different materials, like you need to develop the anode, cathode and electrolytes. So many processes go hand in hand so that you can produce electricity, and you can use the bulb or running your car. So many applications right now we are using fuel cells. The hydrogen need to be stored, which I am my concentration, my expertise on this. We developed the hydrogen motorcycle back in BHU. This is this about motorcycles runs hydrogen, which we developed, and the genset is running with the metal hydride tank, which is loaded with the hydrogen. Number of patents I published for the method of storing hydrogen efficiency on the materials development in 2030 on hydrogen storage technology. On the patent on 2012, which is also how we use nanotech for producing and so we use now materials to store and try to find hydrogen and hydrogen solid, and also they use the hydrogen for fuel cells. But we develop some nanomaterials. This is up to 150 degrees centigrade. We store about 5 to 6% of hydrogen in the materials. This is again our research about you can produce ammonia, but ammonia is not good for the fuel cell. We run the ammonia and crack it down. The ammonia crack it down to hydrogen and nitrogen using the material science. That said, I can take machines. I would like to Noida, India, for the Sciences and Humanities. Dr. Sanjay Kumar Mishra and his team, Florida Polytechnic University, where I am from, University of South Florida, funding agencies like Department of Energy, National Science Foundation, and many other funding agencies. I also thank one of my collaborator, Dr. Meenu Sharma, which I am seeing from here on my list. Thank you again. I can take my questions from you. Thank you.
My question is, Raman sir, how
Yes.
close are we to hydrogen car in India?
How to what?
How close are we to hydrogen car?
Hydrogen
Research is
car, we are not close enough. We are a little behind. In India, still they are not using fuel cells. Fuel cells is a very expensive product. Right now, India is still develop the IC engines, internal combustion engines. But again, I tell you, I promise that the technology is coming up, and probably once we cut down the cost, probably we are close to the reality. So probably another 5 to 6 years, let's say, we can get into the hydrogen technology. Right now, we are running the electric vehicles, so hydrogen is not too far. It may be 5 to 6 years we can realize.
any question from audience?
Sir, I am Dr. P.C. Jha.
Yes, sir.
I want to ask that if we compare hydrogen as a fuel and solar energy,
Yeah.
so which is more beneficial cost-wise and efficiency-wise?
First, I will tell about the solar energy drawback. The solar energy is completely inexhaustible and renewable. The one thing is off-peak is one of the challenge, because if there is no sun or there is no sunlight, then probably so you need to depend on the hydrogen storage, or probably you can use another modes. So that's the one this drawback of the solar energy handling with is intermittent off-peak that puts you in trouble, like you cannot use the solar energy. But there are some techniques like the solar convert into electricity. So solar thermal,
Okay.
you can convert directly into electricity. Yes, you can use it for electrical production, like a PVs, like for electrifying your homes, no problem. Solar PV is very good technology. They use photovoltaics. for direct combustion. But for when come to your transportation sector, you need some transportation alternative methods like hydrogen is much promising compared to solar.
Yes, sir. So another question is, can we combine the solar and hydrogen so that we can use solar cell to
Yes.
split H2O to hydrogen, and then we can use that hydrogen to uh, hydrogen as a fuel in a
Yes,
single vehicle?
that is a promising technology where you need the sunlight, the solar energy, and use your cars probably or your home with the PV cells, silicon or amorphous or crystalline silicon solar cells that use it for the producing the hydrogen. So you can produce
Hydrogen.
the electrons from the PV. That electron is used for electrolyzing the water to produce a
Yes,
hydrogen.
sir. Yes,
Yes,
yes, sir.
I can. Yes, that's very promising, and you can use combination of technology. That's always promising.
Yes, sir. Thank you, sir.
You're welcome.
Any question? Okay. Good evening, all. As all good things comes to an end in life, so is the webinar on behalf of ASH Department of ITS Engineering College, Greater Noida. I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this webinar. Okay. At the outset, I thank our guest speaker and resource person, Dr. Sesa S. Srinivasan. We are really elated with your knowledge. We are thankful to our Honorable Vice Chairperson, Mr. Sohil Chadda, sir, Secretary, Mr. B. Arora, sir, Executive Director, Professor Vikas Singh, sir, Director, Professor Sanjay Yadav, sir, Dean, Professor Gagan Deep Arora, sir, ASH HOD, Professor O.P. Chaudhary, sir, and HODs of various departments for their motivation. A special thank to the teaching staff for their support and coordination. Our heartfelt thanks to our students for a active participation. With this warm word and a kind message, we move to the end of today's webinar. Thank you.